So we got Q is equal to Q naught e power minus t divided by RC. That's formula for the discharging. And if you know that exponential is actually the base of natural log. So if we take natural log of Q is equal to natural log of Q naught e power minus t divided by RC. Okay, so natural log of Q will become equal to natural log of Q naught, and exponential are multiplying. So what do we get? If two numbers, if we have log and a multiplied by b, do you know this formula is equal to log of a plus log of b. So it's a rule of logarithm. Okay, so we get natural log of Q naught plus natural log of exponential minus t divided by RC. Now we get natural log of Q is equal to natural log of Q naught, and there is another formula for log, that is a raised to the power b. So b must be written before the log. Okay, we can write the power outside the log. So it will become equal to minus t divided by RC and natural log of e. Now exponential and natural log are inverse functions of each other, inverses of each other. So it's just like x multiplied by 1 divided by x is equal to 1. Similarly, these two are, you can say, inverse functions of each other. So log and natural log will cancel out and we get 1. So natural log of q is equal to natural log of q naught minus t divided by RC. Okay. So this formula, and then you can simply write it, natural log of q is equal to minus 1 divided by RC into t plus natural log of q naught. I have just changed the order. So this is the formula which you can use, and you can plot a graph between q versus natural log of q versus time. Okay, and because natural log of q naught will remain constant. So if you get, so on x-axis we plot time, that is t, and on y-axis we will get somewhere here a value natural log of q naught, and all the charge, I told you, so all the charge stored on capacitor will always be the less than the total charge on the already stored in the capacitor. So you cannot totally discharge a capacitor. That's what it's saying, because there will be a value and this will be subtracting from it. So t divided by RC, if it's equals natural log of Q naught, that time this result will be 0 and the capacitor will be totally discharged. But you can plot a graph, and the graph will look like a linear graph, because this is a linear equation. So you will see find an equation like a graph like this. Okay. So let's just solve some examples related to these graphs and the charging and discharging.